This video demonstrates the steps to set up an SRH-2D simulation within SMS. All of the necessary components have already been generated, and we will cover the details of each in later lessons. We have a mesh as shown here. We have a monitoring coverage set up with monitoring lines and points to monitor the flow and water surface elevation during a simulation. We have a materials coverage that's set up to specify the roughness parameters to use for elements throughout the mesh. And then we also have a boundary conditions coverage to specify the inflow and the downstream boundary condition. First step is to set up a simulation within SMS. We do that by right-clicking in the white space in the Project Explorer, select New Simulation, and then SRH-2D. You'll see that it opens up a default simulation named Sim, and we'll want to rename that to something that makes sense for our project. In this case, I choose to call it a Q100 demo. Now, the next step is to add each of the components to the simulation. There are two ways to do this. The first way is to drag and drop, and we'll do that here for the mesh. So we'll select on the mesh, and just to note, not the mesh generator coverage. We'll select the mesh, hold the left mouse button down while we drag it below, and when we see the bar or the line show up, we can let it go, and you'll see that it's been added to the simulation. Next, we'll add the monitoring lines. And to do that, we select it, and instead of drag and drop, we'll right-click, and then we'll use the other option, which is to apply that to the simulation. Similarly, we'll add the materials to the simulation. In this case, let's select it, and then again, do the drag and drop. And then the last of the four required components would be the boundary condition coverage. Select that, and then we'll go back and use the apply to method. All right, there you can see that we've got the four required components to run a simulation. Now, in this case, we actually have three structures that we can include in the simulation if we wish to represent the pressure flow. And then we can zoom in on those to show you those here in just a minute. You can use the rotate tool, rotate the domain. You can zoom in. You can see downstream we have one 4-span bridge. And then upstream, we have a double bridge representing probably an interstate. Again, those are 4-span bridges. Now, in order to include those bridges in the simulation, first of all, they're identified as 3D structures that we'll talk about in a later lesson. We'll want to select each of those bridges individually, each of the 3D structure coverages, and drag and drop or apply those to the simulation. In this case, let's go ahead and use the apply option. You'll see that as the Project Explorer gets busy, dragging and dropping can become tedious. So most often it's easiest to right-click and use the apply to option. And now you'll see that we've got, again, the four components we added previously, and then we've got three separate 3D structures added to the simulation. Now, before we can run the simulation, we need to set the model control parameters. To do so, we'll want to right-click on the simulation, select Model Control. The Model Control dialog pops up, and you can see we have four different tabs to enter the options. On the first General tab, the simulation description and case name are optional. You can set those, but ultimately the simulation name overrides those. The start time is typically 0. Time step can range typically between 1 and 10. In this case, we'll use a value of 1. And the end time, in this case, it can be, we want to run the simulation long enough to reach a steady state condition. In this case, we've run this before, and it's about 6 hours. For initial conditions, you'll see we've got several options. For this case, for this simulation, we'll use a dry initial condition. Under the Output tab, we'll stick with the defaults for the output format, the English units, and for specified frequency, for a steady state condition, we typically would want to use just the simulation end, just to see the results at the end. But first time running and troubleshooting, outputting the options at a specified or more frequent interval can be helpful. So 5 to 15 minutes, let's go with that for the simulation. Under the Advanced tab, in this case, since we are just running a steady state condition, we'll want to deselect the unsteady option, and we'll stick with the defaults on all the rest of the parameters, and go ahead and click OK. Now we're ready to run the simulation. So if we right-click on the simulation, the best option is to go with Save Project save the simulation, and run. So it does all those three things in one command. And we'll go ahead and do that here. And that's preparing the SRH-2D data file. And soon it should open up the run queue. And while the simulation runs, you can watch the progress bar in the upper right, as well as you can monitor the 5 tabs or 6 tabs along the bottom. The command line, if the model crashes, that's where you can look to see any errors that might indicate this the problem. As you click through here, you can see the net discharge plot, mass balance plot, wet elements plot while the simulation's running, and monitor plots and monitor line discharge plot. For now, this simulation takes a few minutes, so I'll go ahead and fast forward this until we can get to the results. All right, once the process or simulation is complete, you should see the green bars showing 100% complete. If by chance those bars turn red, that means that something went wrong and you'll want to go back and probably review the output on the command line tab. In this case, for a successful solution, you'll see now we have got the option to go ahead and load the solution. Once that solution loads, you can scroll over to your Project Explorer and you'll see under the mesh a folder with a group of data sets that have all of the output from the simulation. You can click on each of the data sets and then cycle through the time steps at the bottom of the screen if you generated output during the simulation. And so you can select on that and cycle through. You can see the domain fill, and you can do the same for each of the different data sets. If you just ran a simulation and set it for only recording the output at the end of the simulation, you would not see this time step window, and the results would only be the last results at the last time step. Well, this concludes then the demonstration for setting up and running an SRH-2D simulation within SMS. The exercise that follows will give you additional information and practice.